everyone, and welcome to Handmade Hero Show, where we code complete game live on stream. We weren't originally going to do stream this weekend, but it turned out that I did have time available to do it. So I figure we might as well take a look at where we're at. And let's see here, if I just go ahead and open up. Really, we were just replacing our collision detector because it came time where I wanted something fairly robust that I could work with for the rest of the game. And, you know, we hadn't really looked at collision detection for basically the entire development process. We threw one in there at the beginning. But we want to start doing things like putting in little, like, you can see like this little glove in here, right? We want to start putting collision detection for stuff, and so we were sort of looking at how that would work, and we have some reasonable ideas of how we want that to go, and it's really just a question of figuring out exactly how to, like, what's the simplest thing and the most stable thing that will give us the kind of collision detection we want without like overcomplicating things, right? Because collision detection is actually a very difficult problem. It's very easy to write a bad collision detector. It's very hard to write a good one, is probably the right way to put it that way. And collision detection in and of itself may not really be the right way to phrase it. What we're really talking about is collision response. So there's one half of the problem is, do two things collide? And that's not necessarily that hard to do. It's still pretty difficult to do well, so I'm not trying to say it's easy, but it's really the response part that's the harder part. Making sure that when you detect that collisions occur, resolving them in a way that always leads to like good results, stable results for the game. That's sort of more the part that is not great, right? And so I believe this is where we were at. I'm gonna re-enable the movement routine here, and you can kind of see where we're at. So this was us looking before, and well, that doesn't look like it's on for some reason, which is weird. Did we not? I thought we left this in a working state last time, but I guess we didn't. You can see here that we do a subdivision count. Oh, you know what we probably did? I think we did the, like, does it accept or reject thing, but it looks like, yeah, that looks like it's in the right place though there. So I'm not sure. I guess when we stopped, I don't really remember, but when we stopped doing the subdivision here, I guess the move entity locally thing, when we were doing the stepping, still allows it to tunnel, I guess, because it's enough of a step. Don't worry about all this. I will explain in detail sort of where we're at as soon as I remind myself where we're at. But at the moment, you can see it looks like it's just allowed to go straight through. Now, let me re-enable the drawing as well. So if we go in here and we turn on push volume outline, and we go ahead and run it here. Let's take a look. Yeah, so there you go. So you can see the green is when it doesn't collide, and the red is when it does. And you can see there, like, so what happens is, and it's hard to explain, but if I stop this from being able to run larger step counts, or I do something slightly different with the desired position stuff, I feel like that would probably tell us. Let me just see here. Results equals true if we were able to get it. Yeah, that seems weird. I feel like this is, I must have forgotten how to turn it, because it shouldn't be doing what it's doing right now. I feel like I'm seeing something weird. Like did we mess something up? Because I feel like this is supposed to stop, it looks like, right? It stops when it can't move, right? It's got a result equals false up here. It tries to move the entity, right? And assuming that it was able to move the entity, it would set the result equal to true. And if it can't, it just leaves it at the from P location, so wherever the entity was when it started, right? And so this should, and maybe it's just because the step count was too low or something like this, it should have stopped when it hit things. And I don't know. Like, it could be that that number is just too low or something, but it should have stopped when it hit things and not have been able to keep going through, but I don't actually know. Like, yeah, like you can see it's even red there, so I'm not sure how it's able to penetrate through. It looks like it doesn't care that the collision detector said it can't go any further. So I would have thought that would have stopped it, but for some reason it doesn't actually seem to have. And so we'll have to look at that because I thought we were at the place. But either way, it doesn't matter because the point is where we got to last time, even when I go figure out what got messed up in here, it's not sufficient because we didn't have a good way of looking at how you moved through the world and determining that you could or couldn't move out of a position that was interpenetrating was mainly the problem. And so, yeah, so I'm not sure about this. So I'm going to take a minute to just look at this and figure out why it's not stopping the player currently, because I want to make sure it's back to the state that I thought it was in, which it obviously isn't. You can see here where we do the testing here. It starts out assuming that it's going to go to from P. It then checks to see when the... Oh, is it because of how we were doing the voxel marking or something? I don't know. It tests to see whether or not it can be placed at each point in the voxel, and then what it does is it just says, hey, for every square in the voxel of the motion, we're just going to go, what's the one that has the closest point to the place that we're trying to get to, and then it moves it there. And this part here, the step count thing, that was just a way of us trying to figure out, like, hey, if we're going to do motion in this way, we want to make sure that we can't tunnel, so we need to make sure that the maximum step size is fairly low. Now, this part here was just something we ad hoc threw in just to see what it would do. And it's not really something that we probably want. We want our collision detection to be fairly stable, and so we probably want that voxel size to be fixed. We want the voxel size to be like a certain size that is always the same. And we probably want to make sure that the voxel size doesn't vary just based on the movement, right? And so... I mean, the question here is, do we just keep going and go into a subdivision kind of a thing? I think we probably want to do that. But like I said, I don't know what went wrong here, so I'm just gonna drill it down into this a little bit more. So here you can see what we're doing is we have a step count, and we're basically subdividing the motion into steps. And what we do is we try to get the player to move along each of the different steps with the understanding that, you know, the distance that it has to move has to be capped to a certain size. And if we look here, I don't know why. So what we're doing here is we're saying, here's how far this thing wanted to move. The number of steps that will take is going to be however long that is minus the motion displacement size, which is the maximum amount we want to allow a thing to move. And the reason for that is that if we want to allow arbitrarily large movements, we would then have to make sure that our collision detection prevented tunneling through objects of basically arbitrary size, right? And one of the things that I would like to do is exploit sort of efficiency gains we could get by having some kind of a known worst case where we're like, look, there is no thing that is there's no point in the game where there will be something thin enough that it's under a particular thinness threshold so that we don't care if you tunnel through something that thin, right? Like, we're just going to say everything in the game is at least this minimum thickness. And once you say that, then you can exploit the fact that you never have to look for tunneling below that threshold. Whereas if you say that things can be as thin as they want to be, you kind of put yourself in a position where you really have to crank up the complexity of the routine, because now you have to handle any arbitrary little slivery thing you're basically saying, right? And so I'd like to make our job easier by just saying, look, we're going to have some kind of a size here that we're going to say we just don't check for tunneling below this threshold. And the reason for that is just purely for efficiency. If we want to make a robust collision detector, it's way easier to make an efficient, robust one if you have some lower bound that you can guarantee versus no lower bound you can guarantee. So if we take a look at the total length and we look at how much displacement there is, that's saying here's how many steps we're going to try. And I guess when I look at this, I realize that this is not... It feels like this must not be triggering, because it should be the case that as soon as it tries one of these micro steps, it's basically doing micro steps, right? It's saying, I'm going to try at the various places along this line that are however many steps there are, right? I don't know why there was a minimum step count here of anything other than 1, because you would think that 0 would be the only invalid step size. So I'm not sure what this was designed to do. Oh, that's... No. That's the minimum. It's basically saying don't take more than that step size. Sorry. So, okay. So, yeah. Whatever, you're basically saying, look, we don't want to try harder than this. The problem with something like that is this part here has to be obeyed for the routine to work, right? So we're pretty much going to have to do, to ensure that we're always at that minimum size, and that's just kind of how it has to go. And that's fine. So when we look here, let's see here, does that change things at all? Yeah, so you can see that even though we're doing that step size, it doesn't matter, right? It's still able to go right through. And so what I want to look at now is how that's happening, because this means we should never be asking for a step that's larger than that, because we start at the original entity P, right? The place where it started at the beginning of the frame. And then we just ask to move little increments, and we know that the increments can't be more than this, right? Unless I'm wrong about that. T-step. Yeah, because it's whatever the motion, the total amount of motion, we just take the percentage we are through the steps, right? Which is that. And we just look at what they are. So that should be, it should just be like boop, 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 right? And so looking at this, the question is, why is move entity locally seeming to think that it can keep moving it? Because you would think it would stop, right? So if we take a look at what happens here, we start out by saying, well, we've got, and I guess we should check this part as well. So we go through here and we say, look, we've got a thing called allows motion on collision, and that's a thing that is going to be set on anything that's supposed to that you're supposed to be able to move through. So that's like the room boundaries and stuff like that. But otherwise, whenever something intersects, we set the occupied flag on that part of the voxel to true, right? So we march through each part of the voxel. We set it up so that if something intersected at that point, and we just test the two rectangles here, the thing that's moving and the thing that's blocking it, we just set it to true so that we know that part of the voxel is occupied. And then we look through the voxel, and we just look to see if there's any voxel cell where the corners were all open. Then we take that cell, and we allow you to move anywhere inside that cell, which, again, is not what we want to do at the end of the day. But because we then say that you were able to move at that point, if you weren't able to keep going, it should return false, and it should stop this loop. And that doesn't look like what's happening. So I feel like there's something that I busted in here or that's wrong. And that's really the only thing that I was saying I wanted to get to the bottom of first. Now, if we look at how this thing is working, So one of the things is, as we iterate through this voxel, we have sort of the concept of the base of the voxel, right? And the base of the voxel is going to be based on this voxel bounds here, right? So we do this rect min max, and basically what we're doing is we're saying take the from position to to position, consider those to be two corners of the box. And we use the min max here to just make sure that we take whatever the box that encloses the place we're coming from and the place we're going to. We then add what looks like a very large, and this is probably the issue right here. It looks like we then add a very large apron to it. Well, no, 0.1. That's not large. What am I talking about? That's pretty small. So never mind. That's not the problem. We add an apron around that, and that gives us the voxel that we're going to search. We then move through that voxel, doing the testing, like I said before. And we do the cell dim, which is just whatever the voxel bounds are divided by the voxel dimension, which is exactly what you would expect. So that all looks... I don't see anything weird there. I don't know, maybe other people do. We iterate over the What is this? What is that? Do we know what the heck that was supposed to be? I guess we just forgot to delete that. That's not a thing. So we have the voxel dimension, we have the cell dimension, off we go. And then later we iterate over the same voxel, and we start at the from piece. So in theory, and just to check the assumptions here that I'm making, the assumption is that if I block that out, so I don't run this loop, I shouldn't see any movement, right? It shouldn't go anywhere. Nobody should be moving. Okay, so right off the bat, you can tell that this is busted for some reason, right? Because there, I'm literally not updating this thing, or at least I didn't think I was, and yet it moved, right? So something's busted here, and I don't really know what it is. So we got to figure out what's going on there. So when I say move entity locally, it looks like I'm passing some stuff to this. What am I passing? I'm passing the entity from P and the entity to P. So that looks kind of weird. But no, that's okay, because no, it's not. So this is what this would be a problem, right? Although it still shouldn't have moved, because the best P should now just be always the from P, which is the entity P, so it should never change. So how is it changing, right? In here you can see, oh, what the heck is this doing here? Did we just hack that in for some reason? So that whole time I was looking at this routine, it was just because we always moved it forward? Why were we doing that? It must have been something we were playing with the last stream. So that whole thing was just probably because somebody threw that line in there. That somebody is unfortunately me, so I can't blame somebody else. I would like to. But yeah, I don't know what that was doing there. It's fine. I wanted to reacquaint myself with all the stuff we were doing anyway, but yeah, okay. So now we're back to a better scenario, which is that I think we're at the exact place that I wanted to be, if I had noticed that thing was there. And that is, as you can see, it actually looks like everything's working fine until you get embedded in something, right? And this was one of the things that we really want our collision detector to handle, so it's not a good situation. But what you can see is, like, for example, the gameplay code, just because it doesn't care and wasn't thinking about it, it initially creates the glove embedded in the floor, right? And what you can see is when this thing moves around, you don't... How should I say this? Because we only allow motion if all of the squares of the voxel around you are open, and we don't really search outside of the place you're trying to move very much, you can't really get out of things very effectively, right? because we don't subdivide. If we see that, like, oh, where you are, if you would have been moved backwards a little bit, you would be out of the thing you're in. We don't really have any way of dealing with that kind of stuff at all, right? And that's not good, because one of the things we need is literally that. So we end up with a problem that is a conceptual problem. I'm not sure what the right way to change how we're looking at the voxelization problem is if we want to ensure that we search for places to put the player when they come too close into contact with things like that, or the glove where it's embedded, right? I'm really not sure how to phrase it. My guess... It's easy enough to detect that it happened because we kind of know that we didn't find, like, we know when we don't find any place to put the player, right? That's a condition we know because we look through the voxel cells and we don't find anything, right? All of the voxel cells are partially occupied. So when we know that, I'm wondering if that is like the thing we then act on and say, well, we gotta widen the search area or something like this, right? And again, I'm just not sure. When you look at, like, the move entity locally routine, you know, I could think of some, like, hacks that sort of help, but I don't think they're really sufficient. Like, if you take a look at what's happening with the apron size here, you could imagine orienting the voxel so that it includes a wider apron of search, right? And again, I'm just not sure. I guess the way I would say it is this. If the voxel that the person starts out in is considered open, then you pretty much don't have a problem, because that means that there isn't any nearby collider. If the voxel that the person starts out in is the voxel the person starts out in is not open, then that is the case that we need to handle. And so what we may want to do is take action on that case. When we see that case, we probably need to change the idea of what we're doing. Because at that point, we're saying this thing, especially if we detect that it's actually embedded. So if all of the voxel corners that the player is, or not the player, but the entity that's moving, if all of the voxel corners are all colliders, so they're all marked as closed, then you know that the player is the entity is literally embedded in geometry and needs to be moved out of that geometry, right? So we kind of need a strategy for that, right? And I'm not sure. I'm gonna say something now, and it may be totally false. But if you are in a cell that is partially colliding, we could allow you to move toward the part that isn't, right? So that's thing A. Thing B is that if we detect that all of them are colliding, then we could try to move you in a direction that is towards someplace you can go, and that's the part that's a little tricky, because how would we know where that is, right? How would we know where you actually can be placed? And I guess you just have to do a very wide search at that point, so it's just kind of like a fallback kind of a thing. So yeah, so this is very tricky, but I'm liking where it's going. So like, for example, in here, what you can see is this probably wants to be done a little bit differently. Probably what we want to do is say get closest point in box. And when we do get closest point in box, we probably want to allow you to in fact, do we just want to allow you to move anywhere in the box that's towards corners that are open, right? So what we could do is say, I'm trying to think of the most efficient way you could code this, but like, we look at the corners of the box. So when we get the closest point, that closest point is going to be on like one of these features, right? Either it's inside the box itself or it's, its features. We should then be able to say that displacement is going to it would have like, we only need to check that displacement. So I'm thinking that it's more like sine it's more like sine of didn't we have a sine or 0? Looks like we don't have a sine or 0. I thought we did for the octagonal, the octagon thing, but I guess we don't. So, but it's sort of like, I just want to know what the sign of this thing is, right? Which direction are we going to look? And so yeah, like, I think we can just do something like so dir offset or something, like a directional offset, and we just say, hey, what's the direction this thing is going? So we have the delta, right, and it equals, or actually we don't even need that. It's literally just like, you can see what direction we would be going, and in fact, I guess we have to do that in here, right? So we produce the test P and the 2P, right? So we have the closest point in the box, and we just see whether or not that motion would have been open, right? And I guess I'll do it here. You might be able to save this work because it would be basically the same. But so here's us doing that computation, right? And we say, get the closest point in this voxel cell. We then just say, well, we have the test P, right? And we have the from P. So we know we are coming from here. Okay, I don't know what that did. We're coming from here. So we want to know, like, is the from P less than the test P x, right? Like, are we going from a lower value to a higher value of x? And if we are, we want to look at the far end of the voxel. If not, we want to look at the close end of the voxel in x. And if we just do this, then we know which part of the voxel we care about, right? And so from that position, it seems like then we could tell, like, do we need to stop or not based on whether the stuff in that direction is positive or negative. It's kind of a long shot, but I want to see what that does. So if we try that, and I basically say, like, okay, let's nerf this saucy gentleman here for a second. And let's just try a different if statement where instead of testing the entire voxel, we're just going to test a subset of the voxel. And that subset is specifically the part which we just computed, right? In fact, we just only test one? That seems nuts, and I can't imagine this will work. But I don't know. I'm going to try it, I guess. I don't imagine that will do anything good, but I just want to see. Like, so if you allow people to always move towards whatever part of the voxel is positive, what happens, right? And I don't know. So I'm going to test this on maybe some of these floating heads over here to see what they do. I have no idea what they're going to do. But we'll see. So if I kind of come through here, right, or these two together, so it's not like catastrophic or anything, right? It seems to still work, sort of, and those guys don't get stuck anymore. So things that weren't stuck to begin with don't seem to be getting stuck in that way. Things that are currently stuck do still get stuck. Like the glove could not get out, so that doesn't help. But it's at least interesting, right? That's at least interesting. So that shows a little bit of promise. Yeah. So I don't know. I might actually leave that in for a little while. Yeah, I might leave that in for a little while. So that looks like no, because then that looks like they got stuck, right? See, they got stuck on each other, at least a little bit, right? Where they're trying to move crosswise. Although, well, actually, that's, I guess, what you would expect, because they are trying to move. If they're both trying to move to squares where they actually are pushing into each other, they don't have any AI, so they're not smart enough to know that they shouldn't do that. Why can I not move into that square? What's that about? Oh no. This dude is like stuck underground. That's crazy. So he's occupying that square and somehow got placed down there. Not a great sign. So I'm okay with that. I might leave that in for a little bit. I'm at least going to leave the code path in there for playing around with. But again, this doesn't really help us if... So the fundamental problem of if something starts out colliding, we don't have a solution for this, right? So my assumption is that if something starts out colliding, what we should probably do is just allow the motion. And if I remember correctly, like, we couldn't do that. Like, this part here, we can't do, because if we just allow the motion anytime, you can just tunnel through anything you want, right? So we can't just set this to 2p and call it a day. Although thinking through that, the only reason that's true is because currently we don't actually consider the placement move to have worked if there's only one cell. Okay, so actually we might be able to do that. I mean, I'm kind of leaning towards actually just doing this in the stack way. Like, can we just actually have the voxel go the way the voxel goes? Like, can we just say, all right, so let's slightly change this. Let's start in the voxel. So we know, like, we did the from P to P nonsense, right? So what if we just actually do a thing where we say, hey, let's just make a stack and let's pathfind through the voxel for the motion? Because then we could. Then what we could do is say, look, if you start out completely inside, we just accept the motion that you requested, right? Because if we can't find anywhere else to put you, then we're going to let you go. Whereas if we ever find any place that had any things that were open at all, then we won't, right? We will consider that successful. In fact, we could even do that right now in a crappy way, right? You would just say this. And then what you would do is you'd take this. I should probably not quite do it that way. So what I could do here is say, all right, let's set best P equal to 2P in the case where there wasn't anything open. So we could do that right away by just saying like, oh, okay, well, if all of these are occupied, so basically you AND them all together, like so. I could just say like any open equals any open or not all closed, right? And now you would know, like, if you found somewhere to put the player, then you prevent the move. But if you don't, then you don't, right? And so in theory, that would allow interpenetrating things to get out of their penetration fairly easily. I love the springs, the undamped springs. So, and you'd be fine, right? And so the only problem there, again, is that, like, we're going to be allowing things that maybe we shouldn't allow. I'm not sure, like, I can't say for sure why. Is it just because it's too small that we end up allowing that to move through? Because I guess it's because we don't check enough behind you, but shouldn't the place where you start, shouldn't that have been valid? It seems a little fishy to me, so something's a little off. I feel like we've got issues here, right? I mean, this isn't great as it is, but it shouldn't be as bad as that. So I feel like something's up. You can see here we're just saying, like, if all of these are occupied, then you can't place it there. Whereas if any of them were, then there's an any open, so that it should allow you to place it if any of them were open, or if there were no places to place the thing, right? So yeah, I don't know. I don't know why that would continue, especially because you've got the apron size, happening here. So it should be like looking slightly behind. And that just seems, it doesn't seem right. Although I suppose, with this still in there, that part may be busted. But it doesn't quite seem correct. Yeah, and it doesn't even need it, right? It can tunnel through even without that. So it seems a little bit busted. So I'm a little bit worried, and I feel like more or less at this point, I don't think I'm going to have a lot of choice but to have better visualization of what's going on as we kind of explore through here. Because at any point when I'm doing this, I could just have a bug, right? And without being able to see more carefully what's actually going on, I won't be able to, I really won't be able to like debug, right? I won't be able to know if a test that I did failed because it actually was a bad approach, or if it failed because I just didn't have, I had some bug in there that made it appear like it didn't work when it should have. So there's a couple different routes I can go with it, but that's just something that was in my head at that point. So looking at this, yeah, I would say like it's weird. That part is weird because it seems to me like any open should always be occurring, because wherever I placed the thing last time should still be valid as people are moving around. It seems like it should say, oh yeah, there were places you could have been. It's just that they didn't have entirely open edges, so we didn't place you there or whatever. Or in the other case, it's like we looked at the place where you were trying to go and we said that was closed, so we stopped you. But it shouldn't have actually triggered that that any open case. So that seems weird. That seems weird to me, to be completely honest. Yeah, I don't know. I don't know, but that seems weird. That doesn't make sense to me. It doesn't feel like that's what that should be doing. So if I were to go take a look closer, I'm curious if what we have for visualization currently can give me at least some clues before I have to go further down that particular rabbit hole. So one of the things you can see is that, like, on a particular frame, I guess it would be nice if we had a little bit more of an idea of, yeah, I kind of need a good, like, vantage point there, yeah. So you can kind of see, like, as it moves very slowly through there. So it's like accepting the first. It looks like it's doing. It is literally failing that check. The any open check is not coming back true. But how can that be? Because especially when you add an apron at the beginning, so you're looking somewhat behind you, right? How can it possibly be the case that you couldn't have found a place where at least one of the things was unoccupied, right? It doesn't make a whole lot of sense. Now, this part, I suppose we should maybe think of this more like a tetrahedron. And so, like, you know, if this had actually worked and this hadn't, I have some ideas about why that would be. The weird part is this one requires that you be able to move through the entire cube, right? Or it won't accept the motion. And so when I come through here and we just say, like, okay, you know, I'm still able to push through, my question is, like, how is that even remotely possible? And if I turn off the any open part of that, right, so that's not happening. Right, I can't test it. I guess what I could do is move the glove up properly so it's not starting down in a bad location like that. I could probably do something like that. So here in the add player call, you got, you know, all this nonsense. You place like the glove P at whatever the position is. I can say something like that and just force the glove to not be interpenetrating, right? So I guess you can. Well, but it's still allowed to go straight through thing. It's very hard to tell. Like, this is very weird. I feel like I must have some kind of bugs in here, right? Because it doesn't feel like it should be able to do that. And there's a bunch of things in there that are still like, I'm just like, okay, yeah, you could, this allows tunneling and that allows tunneling. So it's not like I'm surprised that it's tunneling, but I am surprised at the way in which it is tunneling currently. It's not what I would have expected it to do, right? So that just seems really strange. It doesn't make a lot of sense to me how that's working. I literally have no idea. I feel like there must be some bugs in how that's working. Can I tunnel the glove through a door or only this guy? And it won't go through unless I get up enough sort of speed, and so, I suppose. But it definitely goes through, right? I mean, or at least seems like it does. Is there any way to get it to, like, yeah? I guess I don't know. Maybe it doesn't. I feel like it does. I mean, I guess what I can say is that, like, all right, so this case here is obviously triggering, though, because no matter what else you want to say, if I enable this case, it can tunnel trivially. So that part's obviously busted. And so maybe, like, we just first say, okay, figure out why that's not working the way that I think it should, because, like, why can I just tunnel through that guy trivially? So why is any open when we look through here? Let me make this 100% explicit. So any open is normally set to false, which means you didn't find anywhere. This code, right? I mean, this code is actually easier. I mean, I don't even really need to do it that way. So let's just say this. Any open here, right, just says if these rectangles intersect, then it's equal to true, right? And so in here we could just say like, open counts equals 0. Or let's say closed count, occupied count. And we could just count. And so here you just do, look, if there's something open, if the occupied count equals, voxdim cubed. Or I should say it doesn't equal, right? If there aren't as many people occupying locations as there are locations to occupy, then it's not opened, right? Right? And so at least now we know, like, okay, there isn't some weirdness with the check, right? And it is easy for it to tunnel through, at least that way. Yeah. It's pretty easy for it to tunnel through, right? It's not really having trouble going through. So that means that most of the time it doesn't think there are any of them open. Normally I would say that's because this is happening in a loop. So after you do the first step of the loop, well, it's open. But in here, it's actually not allowed to continue if it doesn't find a place to put the player, right? Or the place to put the entity. So that doesn't really make sense. It's just a real puzzler. How can it not have any non-colliding corners of the voxel? It just boggles my mind. I do not fundamentally understand how that's possible. So assuming that the motion displacement size itself was the apron, does that change anything? Meaning if you give it more room to search, do you get worse or better behavior? And this is just me trying to provoke the thing, right? Yeah, I fundamentally do not understand what's going on. Like, I clearly just have no idea. I think this routine is working one way, and it is not working that way, right? Because it should not matter how you put, like, you shouldn't be able to get the two different results there. And you clearly can, right? Like, how is it able to push in like that when it's so obvious that you have a thing behind you that should be occupiable, right? And you're checking a whole 0.1 behind you for places to put. That just makes no sense at all. That makes literally no sense at all to me. So what are we doing wrong? How are we getting in a position where the last frame, we thought there were plenty of places to put both of the people, And then on the frame that comes in, we're like, no, there's nowhere to put. There's nowhere nearby. How is that possible? I guess because both entities are moving, and they're moving in a different way, so they each have different bounding box sizes. I mean, but I mean this literally requires. Yeah, I feel like, do we just have some kind of a bug, like with the way we're doing like the intersection testing or something? Like, is this just wrong? You know, or like, is there something kind of like? Because I don't see it. I don't understand. Because the size of the voxel cell in this case is going to be like, or should be like, quite small. You know? So, I mean, here's another thing. Let's take this out of the equation. So, what if we just said, look, you don't, we're not gonna, fine. Uh, I don't really want that. I want that. We're just gonna only do the first micro move. Right. So now we know the loop. So just in case I'm wrong, and we want to make sure the loop can't be contributing, right? I just want to know if the loop can't be contributing. Yeah. So we're only doing the first step. That step is only the size of one motion displacement or lower. We are adding to it one entire thing of that size. What am I missing, guys? Like, what am I missing? Because there's no way that should be happening. Like, I cannot plausibly come up with an argument for why that's happening. So something here is odd. I also don't know, like, what is this about? Yeah, I was like, what are those even doing there? So, like, something's weird. Something's very, very strange. Something is very, very strange. And this code, it's worth noting, is basically the same code. The only difference here is that you're testing who is on the grid and who is at their actual location is different depending on who's moving. And so, I suppose that that definitely matters, right? Yeah. So I don't know. I'm about ready to call it. I'm about ready to say, like, look, I obviously have no idea how this is working. I'm totally wrong about my mental model. So it's time to, like, we have to have debug capture of this thing, which is a big investment, right? So you don't do it unless you have to, but I think we're going to have to. Not because I think this collision routine at the moment is very good, more just I don't feel like I'm going to make good forward progress on it if I don't understand why it's breaking the way it's breaking, because it means there's something wrong with my mental model. And while I don't want to spend, 4 hours or whatever writing something to visualize it, I don't know that I'm going to have a choice, right? Because without that, I think we're just dead in the water fundamentally. Looking at what we're looking at. So I guess I'll ask you guys, what do you think? Do you think that we should start the visualization process now, or do you think, what do you think? Oh, by the way, Suspect Zero, no, the reason for the lag is because it's hard to see because it's difficult when you're just popping into some code like this. So do you see this code right here that says replace with visualization? This is actually looping for every time we do a check on one of those voxels. We're actually looping over all 2,000 entities, 3,000 entities. Yeah. The reason that you're getting the lag is there's no spatial partition for that collision check. So I'm not worried about that right now because the spatial partition part is very easy by comparison to the collision part. And for another reason, I kind of like the lag being in there because having the lag in there helps me see what this thing will do in a bad scenario, right? If that makes sense. Like, it helps me go, let's suppose the game actually did lag out for whatever reason. This is what's going to happen to the collision routine, right? So I kind of like that. Normally, I wouldn't like that. If I was testing like gameplay code and how it felt and stuff, I would be like, oh god, we got to fix this. But right now, I'm like, the fact that this routine itself is causing the lag is great because it means I get to see what it does under bad stress, which is exactly when collision routines fail. And so I will leave that in till it's done, basically. And then I'm going to replace this loop with a spatial partition, and we should have no lag at all at that point. But until then, I kind of want it. I could add a thing to artificially introduce lag, but it's if you have a natural, unpredictable, bad source of lag like that already there, why bother? Just use it, right? If you don't have one, though, you can add, and it's a good idea to add, a slider in that you can, like a debug slider, that you can crank around. And that's pretty cool because it lets you test your systems against lag, which you always should do because you never know, Windows does something and your game was running at 60 frames a second, but suddenly it's running at 10 frames a second for 5 frames. If you didn't have some protection in there to make sure that wasn't going to screw up, you're very sad, right? Because anything can happen. Dude alt tabs to a Zoom meeting and then alt tabs back or whatever, and you get these like Windows hiccups or whatever, and then the game blows up, right? Like, so you want to make sure that you've got in your like defense against weird crap like that, capping things, making sure nothing breaks. It's just a good thing. So I actually like having some lag in this particular part of the code so we can see what it does. I want to check one quick thing, which is just I want to see how iterate voxel does. Let's step through this code once. We do have something that we can do, by the way. So one of the problems, one of the things that's rough, right, is because lighting is so slow. When we switch to -OD, if you notice, like when we run, like it's really hard to run because the lighting is so slow in debug mode. It's like difficult to do anything, right? The lighting just eats up all the frame time, and you can't, like, here's the debug build, right? It's really annoying. You know what I'm saying? And so one of the problems is Visual Studio, you can't turn on and off the optimizer very easily with the Pragma. You have to basically like be in an optimized build and turn off the optimizer or things like this. Well, it turns out apparently that documentation was like wrong, and you actually can, or so claimed someone who emailed me. They were like, I tried this turning on optimizations in a debug build and it worked, so you might want to try it. So we could try it. Let's take a look. So if I go into the lighting thing and just do like a pound pragma optimize, and I'll have to look really quickly, if you'll forgive me for a second, at what the actual switches are. They sent me, they were like, it's these. That they claimed worked. So we can try these and just see. Okay. So it looks like the answer is you do Pragma optimize GT on, and it supposedly does actually turn on optimizations even that you didn't have on in the flags. And then you just say go back to nothing on, and it will reset to whatever flags you did have. Right? Supposedly this works. I don't know if I believe it, but it's a pretty easy thing to test, so we can test it, right? So let's take a look. So I've done it as they suggested, and I can look and see how the lighting fares here. Doesn't look particularly good, though. Let me try some stuff with like the collision detector off. So if I go to assuming that we don't do the collision detector, so we know that it's not causing us a problem. So we just do like, hey, when you try to move an entity, it doesn't move. Like, entities stay where they are, no code gets run. You know what I'm saying? So I run it, and what do we get? So it might be, it feels better than not having it. I'm just not sure. Like, it still seems like the lighting is not particularly optimized. I'm wondering if that is like, well, so there's some other things like the light atlas. I don't know how this pragma would work exactly, right? The other problem is like the math code. If that doesn't have the pragma around it, I don't know if this really is useful, unfortunately. Like, I don't know like if you need to go in here and start, start putting optimize on that stuff. But it doesn't seem good. In the Light Atlas code, I don't know. I could slap them in here as well, just to see. If it's that. But like I said, I don't know. It's better. It's just not like better enough. Like it's not bad. But it's not good. So I don't really know. I don't think that's a long-term solution, so I don't think I'm going to bother with it. Maybe if we slapped it in enough locations, it would help. But it just doesn't seem like it's like if we want to solve this problem, we're probably going to have to solve it a different way, right? So we'll see. Anyway, let's keep going. So if we want to take a look at this code, I just wanted to look at like the voxel iterator and stuff, and just make sure that stuff was working relatively cleanly before I do anything fancier. So here we are in the debug build. Yes, in the debug build, I'm just going to see what happens in move entity when you step into the code for the Vox stuff. I'm just going to take a quick look and see, just to make sure the code is like sane, right? And from there we'll go further. So okay. So assuming I step in here, I'm just going to take a look and see, what the voxel bounds are in this case, and they look fine, right? I mean, they look like what we would have said that you should see, which seems fine. I'm going to look at the voxel iterator. So here's the iterator. It's going 444. It's starting at 000, right? And here's us going through. And what I could do too is before we actually get too involved in this, maybe let's change this code. Maybe I want to pull that out. So there's like a test point that we're going to test. The test point is here, and that way I can look and see what we end up with for these, and that seems easier to debug and inspect, right? Okay. So let's try that again. I probably want the breakpoint to be like here. Here's the voxel iterator. Here's the test position. And if we go through and just step, I mean, it looks like what we would think, right? I mean, that's what we would expect it to do, so that seems fine. So taking a look here, if we take a look at like occupied count, so the voxdim is like 4, right? So if we look at how many things are occupied, we should get in the any open case, like any open here should be 1. It is. And And so like when we get down to here, we should not be doing that, and we don't. So that's good. There we go. So, I mean, everything seems fine in this code path, right? I mean, everything looks like what I would expect. Let's set a breakpoint here, just for fun. And like, I don't know. I don't even know, like, where's the dude? Who's, yeah, the skull dude. I don't even know. Oh, he's coming. You can see the motion caused by the only being allowed to be placed in the full thing, yeah. So anyway, if I try to force the thing to tunnel through, can I switch back to the main view now? Yeah. If I try to force the glove to get into one of those positions, can I do it? I mean, we know I was able to do this before, right? Like I was able to tunnel the thing through, right? And I'm not able to make it happen right now. I need to have a better repro case here. There it goes. So, okay, that tunneled through, but it never hit that case. Right? So actually, it's not because of that it was able to tunnel. Like, I've got the breakpoint there, and like, unless that, breakpoint's busted, that was not the problem. Because it got embedded into the thing. So this keeps getting weirder, right? So that's really weird. Yeah, so that's able to go and do interpenetration without that case. So what do you think is happening there? That's particularly weird. So it's not allowing motion if it can't find some place that's an entirely open cell. So this is as weird as I thought it was, right? This is every bit as weird as I thought it was. So I have some questions. I have a question. So, yeah, it might have pushed the skeleton up over the glove. I guess that's true. Let's take a look. Is that what's happening? That's kind of weird. So is this something that's only happening because we have, like... Is this something that only happens, when we have large time steps or something? I mean, small time steps? Like, maybe it is actually passing underneath. It is actually passing underneath. Okay. All right. All right, so I guess those skull things, why do they float upwards like that anyway? And then they float downward. I don't know why they do that, but I guess that's a problem. And I have no idea why they're doing that. I guess they go up and down. They like come to rest on a square or something. So this whole time, was I actually thinking it tunneled and it didn't actually tunnel? Hmm. Hmm. All right. Well, that's confusing, but not necessarily bad. I don't know what to make of that. So you can see the glove currently, right, is trapped underneath the dude. Yeah. All right. Well, so I don't know what to make of that. That was interesting. So maybe I should revisit this slightly with that in mind, because maybe it's not as weird as I thought it was, and we just need to kind of fix some of that, and we can start to look at this in a different way. I'm gonna switch back to this for a moment, because I'm not totally sure. Like, I don't actually know in this case why nobody can move. You should be able to move. The glove should be able to move right now. And so the fact that it can't is weird to me, right? It should be able to move in this direction, and it doesn't seem to be able to do so. And that seems bad. I guess, and that's not entirely that's not entirely unexpected. Because in this case, if you're going to look at a particular corner of the voxel, what you need to kind of do is start clipping away pieces of it. So you need to say, like, in the direction of this thing, are there any that I could move towards? And that forms the basis that I could move along, right? So one way to look at it is to say, let's form a basis. We have the directional offset here, right? And we know a couple different things. So we know, for example, this is going to be kind of weird, but bear with me. So what we would know here is something that looks like this. In the voxel, the direction of motion, which we have here, tells us which of the points on the voxel we would look to find out if we can move in that direction. But we are fundamentally looking at four points, right? No matter which direction we're like aiming, there's at least, I mean, I guess at least two, but more like, yeah, you can imagine like a plane, and that plane is going to clip away at least two, but possibly four of the points of motion. So I think what we want to do is say, from our current position, if you were to look at the position plus the movement direction, which of these points would be in play? And or another way to look at it would be like which directions are allowed for motion based on uh the points of this voxel, right? I mean, let's take a simple version of it to start. So if the voxel iterator in the z direction, so looking in the z direction, we could say, like, if all the things in the z direction, well, or maybe we just say if any in the z direction. I'm kind of torn as to what. Really, all I'm trying to say here is the corners of the voxel tell us what the permissible gliding directions are. If they're all open, or all the ones vaguely in the direction we're trying to go are open, then we can just go. But if only some are open, what we want to do is clip the movement vector so that you only move in the direction that those would allow, right? So like when you look at this case, the problem is the glove is probably trying to move upward as well as out, and it can't because it can't actually go anywhere in that direction. But if it were to have just said, well, I can still move sideways, which is partly that way, that's okay, right? So I'm trying to figure out what the right way to look at the voxel pieces are. Effectively, I have like a bunch of diagonal vectors, right? They're pointing towards the corners of the cube. So now I'm starting to ask myself, should the voxel actually be centered so that the points so that we're actually looking at motion from the location we're at? This is a real brain bender. So maybe what we want to do here is just clip the box. maybe what we want to do is just clip the box. So if we said, look, here's the problem with this is it might just not be the right offsets, right? You would still, like, so suppose all of these are trying to go up, partially, so the Z is going to be one up, and all of those are interpenetrating. Well, what we want to do is we still want to move along the one we can, so we still want the X and Y to work, and we just want to use Z0, right? So I'm just trying to think, if we, instead of doing it this way, if we basically went through each corner of the voxel, and or maybe as we step through the points of the voxel, we think of it more like this is a cube. Maybe the cube is around the point. Like they're just regions in space, and we say you could have gone up to here. It seems like you want to know more about the shape of the thing passing through it, though. Right? So that doesn't really seem likely to me. So I guess what I might say is like within some tolerance, you would accept either point. Right? So this is really kind of weird, but let's just hear me out. So we know that we are moving towards a particular side of the voxel, and the tolerance of how we're moving would depend on whether we would... Well, I guess we could just clip the motion out in the direction that wasn't implied. So for example, if we took, this one here, where we said, like, okay, you've got, this is the complete directional offset. If it turns out that that one's blocked, then you try the one without that. You try it without each of the components. So you try it without X, without Y, without Z. And you clip out that movement basis. I mean, I don't know, man. We really should be doing this on the light board. All right, so if we wanted to actually see what happens here, right? So if we were literally just playing around, and we said, okay, here's each of the different movement patterns. So this will check, all 8, right? 2 times 2 times 2. We would check each of the directions X, Y, and Z. And we could just say, like, that it looks like this, right? And so for each of those, we know that a vector going in this direction from, wherever we're talking about, motion in this direction through this particular cell is going to hit whatever, it's going to hit whatever the occupied category is on this thing. And I don't know if we want to consider where the actual point would be. I don't think we do. So I think we just want to kind of carve places that would be, we kind of want to just shrink the box away from these things. So the problem is, like, we were using, get closest point in box, but get closest point in box, we don't really have a good way of, like, clipping that point back out, right? So when we go through each of these, I guess it's just like, yeah, if I'm trying to think of how this is any different from just like looking at a box around the thing. I guess you would go, I'm just trying to get the diagonals in there, right? And maybe that's pointless. Maybe you just subdivide and that's stupid. Yeah, I don't know. Since we're almost out of time, I'm just going to say I need to sleep on this. I'm going to do something slightly different, which is just say, look, if you could stand in this cell area, then maybe we just say that you can go anywhere in the interior of the thing. So, like, if you can stand on this particular point, then we'll let you go. No, that's still not going to work. I don't have a good idea for how to make this be more forgiving there, right? All right, let's try it. Let's try one more thing. So let's suppose that we did something like this. So let's suppose we want to test the direction of motion of this thing. So we say, all right, there's the 4 bases, like, and I'm just going to write them out explicitly. We can turn them into a for loop after. So we've got the dir offset, and maybe I just want to call this dir so it's easier. So let's say we say in the direction of z, we know there are 4 of these, right? Looks like this. So in the z direction, we have 4 things. And maybe we just say, look, if there's nowhere in the z direction that's actually possible to go, then you can't go in the z direction, right? So if each of these then the displacement of the point, you're not allowed to go in the z direction in this cell, right? So when we're looking at the cells, we say, from the location of the player to this location, if there isn't, if all of the z's are occupied in the direction you're trying to go, then you're not allowed to go in z to get there, right? I mean, it's a pretty straightforward thing, right? So we would say, like, test p z equals from p z, right? This is super crappy. I'm just trying to give you an idea of what I was thinking. And then you just do that for each of your directions. So you just go like, look, if we could have gone in that direction, we allow it. If we couldn't, we don't. And that's it. Like, it doesn't really do anything else. You know what I'm saying? And the problem with this is that is great if you're the cell containing the actual starting point. If you're not, it doesn't really make any sense what I'm doing here, so this probably won't work, but I want to leave it in there as the next thing to investigate next time. So yeah. Basically this. right? So X, Y, Z's all good there. This one just needs to be updated for X. So the dir comes in here like so. And this would oscillate, right? So I think it's just that. Like, it basically, you look at the plane of motion, and if anybody could go, you let it go in that direction. If not, then you don't let it go in that direction, and you're not going to update the motion of the player to there. And then you would just say, look, if any of them, so if any of these are available, then you go, right? So then we get rid of, this. And we essentially say something like, how many times we clip, and then here we just say, oh, well, if the clip count is less than 3, then you get to move, right? And the other thing is, I suppose in this case, what we probably want is not that you pick the original points. One, so probably what you do is more like this. You say, we're going to make an attempt to place the point, right? It's going to be the 2p, but we're not going to attempt to place you further along in the direction of travel if we can't in this cell, right? And I don't know. I'm really reaching here, but I like to try weird stuff. That's what I do. So, that's just what's going to happen. And nicely, we still have this case live here, so when I change this, we'll see what happens. Probably a disaster. So yeah, and the direction thing here would be like, this is just the direction of motion, I guess. So hey, it slid out just like I thought it would, but that may have just been because, yeah, like it's just not working now, right? So not great, right? But yeah. So, all right. So then the next question is just like, if we were to do this per cell starting from the cell that we're on, I might make a note to myself here, like, and we can test, and we'll try that next time, right? Oh, we got someone said we had a typo here. Oh, yeah. Thank you. There you go. I don't think that will improve matters substantively, probably, but, we want that fixed. So, yeah. It's kind of weird, too. It looks like it's not able to place things, like... It looks a little weird. As well. Like, it's moving slowly. Oh, that's because of this nonsense, though. Yeah. So maybe next time we start with the voxel and we do pathfinding through the voxel, and that's just what we do, and we see what happens with this kind of a scheme. And yeah, like we're getting closer though. It's kind of cool that I don't know if you noticed, it actually pushed that guy. That guy glided along the wall. You could see the red trail and actually went in through the door on that really long move. So, we're getting there. We're far from our goal, but we're getting, we're making progress. So we'll see. All right. That's it. That's it for today. All right. If there's any on-topic questions, I'll take them. Otherwise, we will wrap it up for today. And I think I know what I want to try next time. I think I want to try starting at the place you're at with the voxel cells and moving through the voxel as far as you can until you hit stopping, right? And we'll see. So if you have any on-topic questions, I will take them. Can you explain the direction check a bit more? Yeah, I mean, I can explain it but I can't justify it because that's kind of just me experimenting with some things. So what I kind of wanted to move towards was saying, all right, we're inside a particular cell. We've tested the corners of this cell. So there's 8 corners. We've tested, we know whether the entity could position itself on each of the 8 corners. So all I want to really do here is say, if we check for a particular exit direction. So if I want to leave out of the positive z, for example, let's say this here was positive z. If we wanted to go in the positive z direction, are any of the points in the positive z direction open? If they are, then allow motion in that direction. If they're not, disallow it. Right? So I've not forgotten to upload day 6032. I'm just getting really tired of YouTube's garbage. They keep making it harder and harder to upload videos to YouTube, and I keep not wanting to bother. So it's just me purely being very annoyed. But I will get to it. So it can't move backwards. Well, again, it's not really so it can't move backwards. It's so it can't move in a direction that's blocked. And it's not really that important to understand this anyway, because I'm just experimenting with this, and I was just like, oh, well, I have a little bit of time here at the end, so let me just try it. But it's not, like, this is not good, right? So it's not really important to understand what's going on here because we're literally just, like, trying some stuff. So it's interesting to understand what we're trying, but it's not like I've really, like, I'm. This is not anything that anyone will care about, including us. Right. No, I'm not trying to prevent the glove from moving under the skull. I'm just trying to improve the quality of the collision detector. That's all. When you're trapped, you don't necessarily have a vector in, right? So take, for example, the starting code where the glove was embedded in the ground, right? There's no vector in, it just started out embedded, right? So what I'd like to do is if you have something like that where the game code, for whatever reason, accidentally places something inside something else, ideally you want your collision detector to just deal with it, right? You don't want that to break the whole game. It's easy to have that happen by mistake. Imagine something's going to spawn an entity at some point. It's like going to create an entity because you did something that says that an entity gets created here, like a new glove magically appears or who knows what, and it accidentally is inside something. You don't want that to like break the whole game, right? So ideally you want, when things are interpenetrating, they can find their way out without needing to know how they got there, because they may just have appeared there. And it's hard. I mean, don't get me wrong. We're trying to do something that's on the high end of the quality bar for sure, right? But it is what you want, right? So it may be on the high end of the quality bar, but it's not for no reason. With the live code reloading, I made a thing where global variables in the DLL can be saved and restored when you load the DLL. Have you tried that before? I thought it's kind of neat. I guess I'm not sure what you mean. Do you mean like our thing? We had a lot of stuff that we did that was along those lines, but I'm not sure which kind you mean. Like we had one where we would just, when you changed settings, it would rewrite a C file that had the settings in it, so the next time you built, it would have them. We have one, obviously, that just like you can change the global variables and just it would automatically recompile them. We did that at one point. Like you'd click and it would recompile the actual constant define, so that if that led to an optimization, it would happen in the thing. We had a bunch of things. I don't know if it's the one like you're thinking. Probably not. But we have played around with a bunch of stuff like that. All right, that's the end of the on-topic questions as far as I can tell, so I'm going to wrap it on up. Thanks everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code. So if you want to try your hand at writing a nice, robust collision detector, you can go ahead and beat me to it. I only program for 1 or 2 hours every week on this stream, on this game. So you should be able to totally beat me to it, right? You've got all week. Give it a shot. If you do, let me know if you find something cool. I'll be back here next weekend to try to move it forward a little bit more. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.